If there was one event that could point to the initial conception of the Mesonet, it would be the historic Tulsa flood of May 1984. It was the worst flood event in the city's history, and there were many fatalities and many buildings damaged or destroyed. It was during that event that Dr. Ken Crawford was the area manager for Oklahoma for the National Weather Service. He knew that if he had access to more real-time county-level data, he would have been able to provide better forecasts and warnings to protect life and property. The idea of a statewide network of mesoscale weather stations stayed with Ken throughout the 1980s. He became aware of the fact that scientists at Oklahoma State University wanted to upgrade weather instruments at their research sites. Their primary goal was to expand the use of weather data in agriculture. OSU and OU joined forces in 1987 to build one system to achieve both universities' respective missions. Ken Crawford came to work at the University of Oklahoma as a director of the Oklahoma Climatological Survey in 1989. Dr. Ron Elliott became the focus for Mesonet activities at Oklahoma State University. Elliott and Crawford partnered with dozens of agencies and private companies in the state to develop the first proposal for the Mesonet. It was in 1990 that Jeff Kemple, the administrative advisor to the Mesonet Steering Committee, identified oil overcharge funds that could possibly be used to fund the Mesonet. He arranged a meeting with Governor Henry Bellman. In 1991, Governor Bellman awarded $2 million in oil overcharge funds to create the Mesonet. Both OU and OSU chipped in $350,000 each to provide the funding for the initial purchases. Right away in 1991, the Mesonet began developing sensor calibration systems. The original setups were homemade works of art, sometimes consisting of Tupperware and plastic tubing. During the summer of 1991, the first Mesonet station was installed in Stillwater. And then the following summer, we began our first outreach program, called Earthstorm, that targeted the K-12 community in Oklahoma. Even though we didn't have Mesonet data flowing yet, we trained teachers on how to use the new data set that would soon be made available to them in their science and math classes. Over the years, we've worked with over 250 schools across Oklahoma. There weren't many options for displaying Mesonet data, so we began our development of display software in the fall of 1992. Finally, in March of 1994, with our first 107 stations installed and operating, the Mesonet was commissioned at the Oklahoma State Capitol. That same summer, Oklahoma had a unique event take place in which an annular eclipse passed directly across the state. We were able to enable the Mesonet's capability to turn on 1-minute data collection during the event and collected 53,000 observations to see the temperature and pressure waves that were generated from the eclipse. During the summer of 1994, we also began a partnership with the USDA ARS Grazing Lands Research Lab that continues today. We operate 2 micronets, one in the Fort Cobb and one in the Little Washita watershed. We do the sensor calibrations, installations, maintenance, ingest, quality assurance, and websites for these micronets. We also began a long partnership with the National Severe Storms Lab in the spring of 1995 when we calibrated the sensors for the Vortex experiment. In 1996, we added a new measurement system to the network through an EPSCoR grant. We added soil moisture sensors at 60 of our stations. That has now grown to over 100 of our stations, and Oklahoma is definitively the world's best source of high-resolution soil moisture observations. With the success of our outreach program to K-12 in Oklahoma, in 1996, we began an outreach program to the public safety officials in our state. The program, funded by the Department of Commerce, is called OK First, and as of 2014, we've trained well over 1,000 public safety and emergency managers across the state on how to use the Mesonet's unique observations to help make local decisions during severe weather. The Mesonet can help from identifying heavy rain rates that warrant the closure of a flood-prone intersection to delaying a high school football game because of an approaching storm with severe winds. In 1997, we were awarded a National Science Foundation's grant to deploy 1,200 additional sensors across the network to measure the surface energy balance across Oklahoma. In 2001, our OK First program was awarded Harvard's Innovations in American Government Award. We were one of 1,600 applicants in this prestigious competition. The state was hit with another historic disaster over Memorial Day of 2002 when a barge collapsed the I-40 bridge in eastern Oklahoma. the Mesonet deployed a temporary station at the bridge site to aid with decisions regarding concrete cure rates based on temperature and relative humidity. The Mesonet contributed to the bridge being reconstructed in record time, well ahead of projections. The Mesonet was being asked almost monthly to host other states and countries to see our operations. After doing this one group at a time for several years, we decided to host an international institute in 2002. We had 144 participants from 25 states and countries attend. In 2003, we began another novel observation by partnering with the OWRB, EPA, and the USDA ARS in installing groundwater level monitoring sensors at our stations that overlaid shallow aquifers. Today, 8 of our stations report hourly observations of groundwater level over the Garber-Wellington, Rush Springs, El Reno, and Arbuckle-Simpson aquifers. During the summer of 2004, we began a 3-year project to prototype a New England Mesonet. We oversaw the surveys, installations, and maintenance of 100 weather stations in Maine, Vermont, New York, New Hampshire, Massachusetts, Rhode Island, and Connecticut. We also designed an ingest, quality assurance, and display system for the New England Mesonet. During that same time, we were awarded a federal highways grant to develop a nationwide ingest, QA, and dissemination system so that road weather data could be easily integrated and disseminated across state boundaries. In 2005, we began another outreach program, this one to fire managers across Oklahoma. The project, titled OK Fire, was funded by the Joint Fire Sciences Program to create a weather-based decision support system for both wildfire and prescribed fire. To date, we have trained over 1,000 fire managers across Oklahoma on the system. As the Mesonet Data Archive grew, we saw the coming importance of creating a climate archive for Oklahoma. In 2008, we created 5 Mesonet continuity sites across the state to test new sensors and provide continuous overlap of original 1990 sensors with new instrument upgrades. During the fall of 2008, we commissioned the Oklahoma City Micronet, a network of 36 stations deployed on traffic lights across the metro. For over 2 years, the network documented the urban heat island and other urban atmosphere interactions around Oklahoma City. In 2009, we dedicated our modernized calibration lab to our first Mesonet manager, Fred Brock. That same year, we were awarded a grant to develop a roadmap plan for modernizing Korea's weather network. Our international work continued when in early 2010, we launched a new Mesonet Quebec website, a culmination of work that began in 2001. 2011 was a unique year for extreme weather in Oklahoma. Beginning on February 10th, our Mesonet station at Nowata recorded a temperature of -31 Fahrenheit. The observation was evaluated by the National Climatic Data Center and now stands as Oklahoma's official record coldest temperature ever recorded. Just 7 days later, Nowata warmed to 79 Fahrenheit, a change of 110 degrees. In May of 2011, an F5 tornado crossed just north of our El Reno station. Our station stood tall and recorded a wind gust of 151 miles per hour, which also goes down as Oklahoma's highest wind gust ever recorded. In the summer of 2011, we began a new K-12 outreach activity by holding our first Mesonet weather camp. As of 2014, we've had students from 19 states and 16 Oklahoma counties attend. The summer of 2011 was Oklahoma's hottest on record. Our Mesonet station in Granfield recorded 100 degrees Fahrenheit for 101 days, setting another state record. Oklahoma's wild weather of 2011 wasn't finished, however. After 18 years of never experiencing a direct tornado hit, a supercell dropped tornadoes that toppled both our Tipton and Fort Cobb Mesonet stations on November 7th. In January 2012, we launched our first mobile app. Through 2014, we've had over 65,000 downloads. 2013 was a year of big awards, starting with the Innovator of the Year award from the Journal Record. Then a $1.2 million one-time appropriation from the state legislature to upgrade virtually every sensor across the network, and we were awarded a grant from state regents to expand our weather camps to high school students across Oklahoma. And in the fall of 2013, we received the National Weather Association Award for the Mesonet's significant contributions to operational meteorology. In 2013, we began prototyping pavement temperature monitoring at our Tulsa Mesonet station in cooperation with the National Weather Service office there. Our Tulsa Mesonet station is also one of our test locations for new snow depth sensors. And at the end of 2013, the Mesonet recorded its 5 billionth observation, which the Weather Channel broadcast on their weekend live show. And this brings us to our 20th anniversary in 2014.